the straight lines, can be parallel lines, can be perpendicular lines, can be intersecting line. Is there any fourth type of straight lines? To answer, what is fourth type of lines? To answer this question, let us take a cardboard and make two holes in it. After making two holes in it, take two pens and insert in these holes. Consider every pen as if a 3D straight line. So, every pen as if a 3D straight line as shown in the figure. Now, if we extend this pen from either side, will they intersect? Answer is, these lines will never intersect from either side, from this side or from other side. If every pen as if a 3D line, so we have two 3D lines, and both the 3D lines are non-intersecting lines. So, straight lines are parallel lines, perpendicular lines, intersecting lines, and fourth type is nothing but non-intersecting 3D lines. So, these 3D lines which are neither parallel nor intersecting. The 3D lines which are neither parallel nor intersecting are called as skew lines. Now, replacing this 3D diagram with simple two lines, first line and the second line. Both lines are skew lines. L1 be the first line and L2 be the second line. Equation of first line is given by vector R equals to vector A1 plus lambda multiplied by vector B1. Similarly, equation of second line is given by vector R equals to vector A2 plus mu multiplied by vector B2. These skew lines are always not same distance from each other, as they are non-intersecting as well as non-parallel. So, if you draw the different projections between these two lines, a situation where the distance between the two lines is smallest. The smallest distance between two skew lines is called as shortest distance between the skew lines. Now, consider a point P on line L1 and point Q on line L2. Draw a projection PQ on this line. This distance PQ is the shortest distance, and vector PQ will represent shortest distance vector. It is a vector quantity, and let D be the magnitude of shortest distance vector. Magnitude of this shortest distance vector. So, the magnitude of shortest distance equals to modulus of cross product of B1 and B2 in numerator and the magnitude of cross product in denominator. And we also find out the difference of vector A2 and vector A1. After that, we find the dot product of B1 cross B2 and difference of A2 and A1. So D equals to modulus of B1 cross B2 dot difference of A2 and A1 divided by magnitude of cross product of B1 and B2. By using this formula, we can find out the shortest distance, the magnitude of shortest distance between the two skew lines. If the equations of L1, L2 of these two skew lines given in Cartesian form, such as equation of L1 given x minus x1 upon a1 equals to y minus y1 divided by b1 equals to z minus z1 divided by c1, and similarly equation of L2 given in form of x minus x2 divided by a2 equals to y minus y2 divided by b2 equals to z minus z2 divided by c2. Can you guess what are a1, b1, c1 and a2, b2, c2? Please write down your answer in the comment box. If the equations are given in Cartesian form, then the shortest distance between these two skew lines is given by the formula d1 divided by d2. What is d1 and what is d2? We find d1 by using the difference of x1, x2, y1, y2 and z1, z2. Therefore, d1 equals to determinant of x2 minus x1, y2 minus y1 and z2 minus z1. In the second row, we use a1, b1 and c1. In the third row of determinant, we use a2, b2 and c2. So d1 equals to determinant of x2 minus x1, y2 minus y1 and z2 minus z1. In second row, a1, b1, c1. In third row, a2, b2, c2. Now, how to find out d2? To find out d2, what you do? You write down the direction ratios as b1, c1, a1, b1, and direction ratios of second line b2, c2, a2, b2. Then you put the arrow marks in this order. After that, we obtain d2. So be careful. Always start from top left to bottom right this way. This is the first one. So d2 equals to under root of. So d2 equals to b1 multiplied by c2 minus b2 multiplied by c1 whole square plus c1 multiplied by a2 minus c2 multiplied by a1 whole square plus a1 multiplied to b2 minus a2 multiplied by b1 whole square. So by using this way, this formula, we can find out d2. After finding out d2, d equals to d1 divided by d2. To ensure positive result, we take modulus. So this way, we can find out the shortest distance between two skew lines if the equations are given in Cartesian form. On the basis of above discussion, here I have solved two examples in very detail, step by step, with all calculations, no hurdles, step by step, and I have calculated till end so that you get total understanding how to find shortest distance between the line. Example 1, I have taken in vector form and example 2 in Cartesian form. So I have solved both the types. These are the two examples majorly asked in every examination in vector form and Cartesian form. And I have solved these both examples in very detail with all steps, and I am sure that you will grasp 100%. So let us understand how to find shortest distance between two skew lines. Here is the example 1. In this example, we have to find the shortest distance between the two skew lines, and both the equations of the skew lines are in vector form. First of all, these two equations are given. Call it equation 1 and equation 2. So this is the first line and this is the another line. First line is L1 and given by equation 1, and second line given by equation 2. Equation of L1 and equation of L2 are given as above, and we need to find the shortest distance between them. Let us call this D, magnitude of shortest distance. Comparing first equation with A1 plus lambda multiplied by B1, and comparing second equation with A2 plus mu multiplied by B2. Of course, they are vectors. Both the equations of the lines are given in vector form. Implies vector A1 equals to I plus 2j plus k. This is vector A1. And vector A2 equals to 2i plus j plus k. Similarly, vector B1, this is vector B1 equals to I plus j plus k, and vector B2 equals to 2i minus j minus 2k. After that, we find out cross product of vector B1 and vector B2. This is equals to determinant of vector I, j, k, 1, 1, 1, 2, minus 1, minus 2, which is equivalent to minus I plus 4j minus 3k. After that, finding out the magnitude of B1 cross B2, that is equals to magnitude of minus I plus 4j minus 3k, which is equals to under root of minus 1 square plus 4 square plus minus 3 whole square equals to under root of 1 plus 16 plus 9 equals to under root of 26. If your vector is not strong enough, then please visit my channel and also visit playlist on vectors. Now next step is to find difference of vector A2 and vector A1. That is vector A2 minus vector A1 equals to I minus j n plus 0k. Since shortest distance between the skew lines is given by B1 cross B2 dot difference of vector A2 minus vector A1 divided by magnitude of vector B1 cross vector B2. Therefore, shortest distance B1 cross B2 nothing but minus I plus 4j minus 3k dot A2 minus A1, that is I minus j plus 0k divided by magnitude of B1 cross B2, that is root 26. Therefore, D equals to modulus here is -1 and -4 plus 0 divided by root 26. This is equals to modulus of -5 upon root 26. Since we have taken the modulus, therefore only we have to accept the positive result. So the distance is always positive, and so distance between these given skew lines is given by 5 divided by root 26. So this is required answer. This is the distance between given two skew lines. So here we had given the two lines, and so this is the d distance, and this distance is nothing but pi divided by root 26 units. So this is required solution. In earlier example, the equation of both the lines were given in vector form. Now here we have to find the shortest distance between the lines, and both the equations are given in Cartesian form. So we need to find the distance between these lines. Both the lines are skew lines, both the lines are 3D lines. Step 1. So this is the first line L1, and this is the second line L2, and this is the shortest distance between them. Shortest distance is given by d1 divided by d2 in modulus form. So first of all, what we can do, you can compare the given equation with standard equations. So comparing L1 and L2 with standard equation, so that we get coordinates and so that we get the direction ratios of each line. Comparing first equation with x minus x1 upon a1 equals to y minus y1 upon b1 equals to z minus z1 upon c1. Similarly for the second equation. Now with the first comparison, we get x1 value equals to 1. You see this is x1 value, and y1 equals to -1. Here it is y plus 1. You can write it y minus of -1. Therefore y1 equals to -1 and z1 equals to 1. And direction ratios of first line, a1 equals to 7, b1 equals to -6, and c1 equals to 1. So these are coordinates and direction ratios for the first line. Now for the second line, this is for L2, and for L2 x2 value is 3. This is x2, and y2 value is 5. This is 5, and j2 value 7. This is 7. And after getting these coordinates, now find out direction ratios for the second line. Direction ratios for second line, that is a2 equals to 1. This is a2, and b2 equals to 2. This is b2, and c2 equals to 1. This is c2. And after getting coordinates and direction ratios, we need to find the value of d1 and d2. d1 is given by determinant. This is not modulus, it is determinant. So determinant of x2 minus x1, y2 minus y1, z2 minus z1 in second row, a1, b1, c1, a2, b2, c2. Putting all these values, we get d1 equals to x2 is 3, and x1 is 1. So x2 minus x1, 3 minus 1, y2 value 5, and y1 value is -1, and z2 value is 7, and z1 value is 1, 7 minus 1. Now a1, b1, c1, that is 7 minus 6 and 1, and a2, b2, c2, that is 1, 2, 1. Now we'll find out. First of all, simplify. d1 equals to determinant of 2, 6, 6, 7, minus 6, 1, 1, 2, 1. And determinant value of this is equals to 2 multiplied by minus 6 minus 2 minus 6, 7 minus 1 plus 6 and 14 plus 6. So 2 minus 8 minus 6, 6 plus 6 and 20. This is equals to minus 16 minus 36 plus 120. So we have 52 minus 52 plus 120. So 120 and 52, subtract them. So this is equals to 68. Therefore, D1 equals to 68. Now we need to find D2 value. To find D2 value, you write down B1, C1, A1, B1 values, then B2, C2, A2, B2 values. So we have here B1, that is minus 6, C1 is 1, A1 is 7, and B1 is minus 6, and B2 is 2, C2 is 1, and A2 is 1, and again B2, that is 2. As I already given you this formula, so putting into the formula, D2 equals to under root of B1. B1 is nothing but minus 6, C2, that is 1, minus B2, that is 2, multiplied by C1, that is 1, whole square, plus C1, 1, A2 is 1, minus C2 is 1, A1 value 7, plus A1 value 7, B2 is 2, minus A2 is 1, and B1 value minus 6. Again whole square. Simplifying this, we get D2 equals to minus 6 minus 2 whole square plus 1 minus 7 whole square plus 14 plus 6 whole square. Simplifying further, D2 equals to under root of minus 8 square plus minus 6 square plus 20 square. So D2 equals to 64 plus 36 plus 400. D2 equals to under root of 500. This is nothing but 5 into 100. This is equals to 10 root 5. Shortest distance between the skew line D equals to D1 divided by D2 modulus. Therefore, D equals to D1 value 68 and D2 value 10 root 5 under. So therefore, shortest distance between the lines is equals to 68 divided by 10 root 5 units. Here we can cut it. 2 5s are 2 3s are. So shortest distance between the given two skew lines is 34 divided by 5 root 5 units.